guys, let us get into this experiment properly to verify Snell's law. That is the second law of refraction, which we already stated, tells us that the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of medium. This constant you are talking about is the refractive index of the second medium where the refraction takes place. So if I have light coming from air to glass, the refraction takes place in the glass. The refractive index will be that of the glass. So here with me, I have this triangular prism. This is your triangular prism. This is your triangular prism. You can say that, right? This is your triangular prism. So this is a glass. We are going to use it to see how light can refract when it passes through this medium. Now the light will be coming from air. Here with me is this plain paper I'm going to use for the sketch. Is that okay? To do the ray diagram or the ray movement. And of course I have my tracing pins. I'm going to use these pins, okay, as my tracing pins to determine the direction of light. So just like you saw in the previous explanation where I showed you how the light rays will move, you know, like in this case it's going to move this way. The light will come from this direction. Okay, let me get my pencil. The light will come from this direction. It will hit this face of the triangular prism. You know, light coming this way, it's coming from air. Then once it enters this triangular prism, it's going to be refracted through the glass. So the refracted ray will be inside the glass. Then on this other face, that refracted ray will now be coming out of the glass. So coming out of the glass, it's entering into air now. That's just the idea of the experiment we're about to run. So like I said, here I have my triangular prism. Alright, there's the glass here. I have my pins. There are 4 of them. 2 will be used for the incidence ray, and then the other 2 will be used for the emergent ray. Is that okay? The emergent ray. Like I said, the refraction or the refracted ray will be inside the glass. I have my protractor. The protractor is for me to measure the required angles, and of course I have my ruler, okay, my rule, which I am going to use to draw all necessary rays. Remember, what I'm going to do here is to demonstrate the experiment. Then after that I would print out the table of values. That's the reading I obtained. Are you getting me right? I'll just demonstrate one on how you carry out the experiment. Then I'll run the rest and show you what the table of value looks like. So let us start with. This is my triangular prism. I'll place it and then draw the outline. Good. So I've drawn the outline of the triangular prism. Okay, I will remove this triangular prism. You know, all these will come in the instruction given to you, okay? If it is in examination, the instruction will be there on how you will have to carry out the experiment. And if it is your laboratory work, okay, say it's not examination, of course, your lab technologies will tell you how to carry out the experiment, or you have a lab manual, okay, which will guide you. So the first thing is to trace the outline of the prism, which I've traced. Let me say something. When I shifted the prism off, I didn't turn it anyhow. Please, I always advise when you are removing the prism, whether rectangular prism or triangular prism, do not go and just turn it and change the way, are you following, right, that the thing was placed when you drew the outline. Because you still need to replace this prism back when you are doing your tracing. If you change the face, you may just get into a kind of problem in order to place it back exactly. Alright, so like I said, I've I'm going to wipe off this excess, this thing here, wipe it off. So let me wipe it off with my eraser, okay? So, good. I've wiped it off. So you can see the outline, triangular in nature. The next thing I'm going to do is to draw the normal. The normal is a line drawn to meet any of these faces, either here or here at 90 degrees, depending on where the incident ray is coming from. I would like the incident ray to come from this direction. Are you getting me? So I will draw my normal here first. I'm quickly going to label here as A, B, and C. So I want to draw my normal now. To draw my normal, I'm going to place my protractor at a point along face AB. Now I'll show you this better. So just watch as I do that. Okay, so I believe you can see this clearly now. This is the outline of the triangular prism. I've labeled it ABC. So I will call here face AB. So along this face AB, I'm going to get my normal at the designated point. Sometimes we might be told, okay, place the normal or draw the normal at half the length of this AB. Whatever the measurement given to you, you use it to draw your normal. Now let me check using my meter rule. This is in centimeter, and of course length AB is 4 centimeter exactly. So I can decide to draw the normal at 2 centimeter. I've made a point at that 2 centimeter. So at that 2 centimeter, I'm going to bring my protractor. Watch. This point of the protractor where the horizontal 0 to 180 degrees line met the 90 degrees line. You can see the vertical line. This middle point, I will make sure that I place it on this point where I'm to draw the normal. So let me adjust it and see. When you are doing that, the horizontal line of your protractor should lie exactly along the length AB. Okay, watch please. This middle point, I am going to make sure it is at this point where I want to draw my normal. And I guess you can see this. Good. So I'm going to trace my 90 degrees out and make a point. So this is my 90 degrees. I'll simply shift the protractor, then join that 90 degrees to this point where I'm to bring the normal to along face AB. So look at it, this is a point of 90 degrees. This is where the horizontal and vertical, that's the 90 and 180 degree or 0 degree line of my protractor met. So look at it. I'm going to join it here. This is what we call the normal. You can draw it into the prism, that's the prism outline. Good. With this normal drawn, then the next thing is to get my angle of incidence. The angle of incidence I'm going to use here is going to be 40 degrees. That's my choice. Like I said, if you have your manual or if it is an exam situation, the instruction will be there for you to know the incidence angle to use. So in this case, I'm going to use I equal to 40 degrees. This angle of incidence will be measured away from the normal. So how do I measure it? Once again, I'll bring back my protractor exactly the way I obtained this point where I drew the normal. The 90 degrees line will go this way. The outline 0 to 180 degrees will be lying here. Are you following right? And so I'm going to place it back. I am sure that you're watching what I'm doing. Good. So the 0 180 degrees line is lying on face AB or line AB. And the 90 degrees line, if you look at it, has come out this way, okay? Now this point, you notice that that is where the vertical 90 degrees line and the horizontal 0 to 180 degrees line met. So I've actually placed this on the outline. I'm interested in measuring 40 degrees, incidence of 40 degrees. So from 90, I will check 40 away from 90. Away from 90, 40 degrees will land us on 50 degrees. So I'm going to make a point at that line 50 degrees, okay? Look at it, 50 degrees line. From 90, watch, 90 to 80 is 10 degrees. To 70 is 20 degrees. To 60 is 30 degrees. Then to 50 is 40 degrees. Make a point there. Then shift your protractor away. Bring your meter rule. Join the point here. This is the point of incidence. Okay, on face AB or line AB. Join it to this 50-degree point you made. So this goes this way. And that gives me my incidence angle. Please do not go and be drawing this line up and down this way. Don't do that. Think one movement is enough. Okay? If I wish to take it further, I can just take it further from here. Good. So this is my angle of incidence, 50 degrees here. This is the angle of incidence I, and 40 degrees rather. Angle of incidence I, and it is 40 degrees. I equal to 40. Like I said, this is the normal, and this is the angle of, this is the incidence ray. The incidence ray giving us this angle to be what? 40 degrees. You knew how I got the angle. I want to extend this incidence ray, please. I want to extend it further. And the reason why I want to extend it, I'm going to dot it. I would like us to measure the angle of deviation for this experiment. The angle through which this incident ray deviated. Because at this point we'll be seeing the emergent ray coming out this way. A ray was incidented in this direction. Instead of going like this, when it is now coming out of this triangular prism, it's going to come this way. So it actually deviated from the original direction that the incident ray was supposed to take. If it is rectangular prism, what happens in rectangular prism is simply lateral displacement. I think in one of my video lessons, I've treated as you can go through the GMAETS 41's physics playlist and you will see the video lesson on rectangular prism. Okay, so having drawn this line, I am going to place my two pins, pin 1 and pin 2, on the incidence ray. So look at pin 1. And then I'll bring pin 2. I'm going to space it a little. They should not be too close spaced. So I'm going to space it. I decide to place it here. This is pin 2. Good. So we have pin 1, pin 2, pin 2. Then on this side we're going to have pin 3 and pin 4. But for us to do that, at this point I'm going to replace the triangular prism back on its outline. Make sure that it is well placed on it. Make sure it is well placed on the original outline. Good. Good. So I've replaced the triangular prism on its original outline. What I'm going to do now is to pick my pin 3 and pin 4. Pin 3 and pin 4. Make sure the prism does not shake. Then you come to this face. You might not be seeing me fully now yet, but don't worry, I'll show you. You come to this face, and then you try to check where you would see the incidence ray. So I'm going to come along this face now, okay? And then I would bend and try to see if I can see the incidence ray in this direction, okay? And of course, from where I am, I'm already seeing it, but to help you see it clearly, I'm going to reposition the camera once again. All right, good. So look at this position now, please. I would like you to watch all the things I'm going to demonstrate with my hands, okay? This is the face you will now be looking through, this face. This is face AC. You can see A here, and you can see C. We actually incident the ray from this other face, AB, face AB. You can see these pins. These are the pins. Physically, you can see it, okay? But you will not be looking at these pins, say from outside here. No, you don't do that. In tracing the refracted ray, we shall be looking at this face of the triangular prism. We shall be looking at this face of this what? Triangular prism. Now, I don't know if you are seeing any pin-like object through this face. Through this face, look through into the glass. You'll be seeing the image of pin 1 and 2 that I fixed on this side. If you are looking through this, to help you see it clearly, please, your eyes should be looking through this face. Your eye should be looking through this face. Don't look at this place. Don't. Because I'm going to take this pen here. My reason is for you to observe that through this face AC, you'll be seeing this pin that I'm talking about. For example, the image of pin 2. Let me place this pen on top. And then you could see the pin through this face. I think you can see it clearly now. You can see. Good. This will tell you that the image of this pin is actually showing through this face AC of the prism. Okay? You can see that. You can see that. The image is somewhere here as you are viewing. Good. Now let me go to pin 1, P1. P1. I don't know if you can see this very well, but it's further away. Pin 1, somewhere, let me bring it down so that you'll be seeing. Please be looking through this face. It is the image of the pin we are interested in. Watch, I'm using the pen to turn around it because if I place it on top, you are not really seeing it clearly. But let me come under. Look at, this is the pin. Can you see the pen moving in circle through this face AC? This will tell you that actually the image of pins 1 and 2 can be seen through this face AC. And it is the image of pins 1 and 2 that we want to block. But our interest is to block the image of pin 2. That is this one, which you can see. Look at it. The reason is because this pin, already the position you are going to take on this face while trying to block the image, that position already would be such that pin 2 will cover pin 1. Such that pin 2 will cover pin what? 1. So let us do that. Another thing that can guide you, my dear friends, look at the line, the incident line. If I trace this, you notice that the incident line, you'll see the image somewhere here like this. I'm using the pencil to trace it. Look at my pencil there. Is it my pencil or my pen rather? On the incident line. So sometimes, if you want to trace, you can actually place something that might be a bit clear if your pin is not so clear. So that you'll be seeing that line. Now, along this face AC, following the principle of reversibility of light, you yourself trying to block the image of pin 2, you are meant to stand on a straight line along that image of the incident ray which you are seeing. Look at, this is the incident ray I'm talking about. You can see the pen on the other side. Then look through this face. Look through this face AC. You'll be seeing that line through that prism. If I use my pencil, raise it up, because your face, like I said, your eye should be looking through this face, through the face AC. You notice the pencil is like blocking the image of the pen you are seeing through this face. This will tell you that the pencil is actually at a point which is likely on a straight line to the pencil. Which means if I want to block the image of pin 2, if I want to block the image of this pin 2, you can see that pin 2 properly now, because I've used something to cover it behind, so that rays of light, okay, will not interfere. Look at it. So if I bring this pen behind pin 1, you could see pin 1 clearly, okay, even if it's not so clear, but you can see something. Look at this thing. You can see my pencil now showing through the glass, face AC. If you are looking at face AC, you'll be seeing the pencil dangling on the image of that pin 1. So your interest is make sure you stand, you yourself trying to block this image of pin 2. This image of pin 2, you that want to block it, make sure you are standing somewhere. If you stand here, if you stand where I am going to put this pen, you can't block the image of pin 2 properly. If you stand here, you can't block it because you are seeing the image of pin 2. You are expected to stand where you will make sure that you are standing on a straight line to the image of pin 2. Somewhere here. So if you are able to move yourself to this point, somewhere like this, to somewhere here, you should be able to block that image of pin 2. Let me use pen. This time around, let me take pencil behind. Let me take pencil behind the objects. There you can see the image now, the image in the pen through this face AC. So I am saying that if you stand here, you can't block it because you are seeing that the image of the incident ray. You are seeing it if you stand here. you'll be seeing that image. You are meant to stand where you will be on a straight line with that image. Think somewhere here, right? Yeah, somewhere here. Okay, think somewhere here. Don't mind the fact that I'm using pen and pencil, it's making the distance big. When I am done, I just want to show you where ordinarily you are meant to stand when trying to cover this. So somewhere here, you are meant to stand somewhere there while covering. So having demonstrated all of this, please, I did this so you can see the image of pin 1 and 2. You will make sure you place yourself along straight line with the image of pin 2. So I'm going to cover now. Watch where I would bring my pin 3 to block. As I block, please, you would find out that somehow you may not be seeing the image of pin 2 if you are on the same straight line. Good, so pierce this down. Good, I've blocked that. Then you bring pin 3. Your pin 3, which is this, your aim is now to block this pin 4 rather. Your pin 4, your aim is to block pin 3. Your aim would be to block pin 3. So let us see how it goes. I'm bringing pin 4 now to block pin 3. I'm bringing pin 4 to block pin 3. Like I said, you have to make sure you're on a straight line to all this, and you should be looking at the foot. You should be looking at the foot of the pins. Now that I want to block pin 3 rather, now that I want to block the foot of pin 3, I will not be interested. I will not be interested in looking at the foot of pin 2. I would not be interested. You should be looking at the foot, not the top, please. If you look at the top, because of bending of the pins, you may just get into trouble. Look at the foot. Look at the foot. Okay, I've not blocked this properly, so I'm going to remove my pin 3. Sorry that you're not seeing me anyway, but I'm standing already on a straight line with the image of pin 2 already. That's the image of the incidence ray. I'm standing on a straight line to read. Good. And I could block this. At this point, I'm only seeing the image. Sorry, at this point, I'm only seeing this pin 4 now. Where I'm standing on a straight line with the original image of pin 2, which I saw. I've blocked pin 2 using pin 3. This is pin 3, and this is pin 4. Pin 4 has covered everything through the foot. If I'm looking through this foot, I can only see this pin 4. I cannot see pin 3. It means I've been able to block the image of pin 1 and 2 through this face AC. Good. So this is how you run this experiment. Like I said, this is the only object I am seeing now in terms of the foot. Okay, if you bend, you would notice that you are seeing the foot of this pin only. While you are bending, please make sure that one of your eye is closed. The eye that is open, you will connect it. The eye that is open, you will connect it to the foot of this pin 4. That eye that is open will be on a straight line with the foot of this pin 4. Remember, light travels along a straight line. So the idea is this: the incident ray came this way, as you could see. When it hit this face AB, when it hit this face AB somewhere here, okay, good. Instead of going straight like this, it deviated. It deviated through this. You can see the ray came out this way. I blocked it with pin 3. Then continue traveling. I blocked it with pin 4. You can see that. Mind you, like I said, always look at the foot of the pin, not the top. The top can bend. Are you getting me? So you may get into trouble if you are looking at the top. Just look at the foot. Good. At this point, you would now remove pin 3 and pin 4 because you would join it. You join the 2 points. Are you following? You would also remove this prism, triangular prism, then remove pin 2 and pin 1 because you are going to join these lines now, and watch as I carry you through. Good. So at this point, I am going to join, all right, this point of pin 3, let me label it P3, and this point of pin 4, P4. I'm going to join them, and after joining them, I'll produce that line. I'll produce that line to face AC of my prism. Good. So this is P4, this is P3. Alright. What I now have to do is, I'll come to this point where the ray touched face AC. See this ray that came out this way is called the emergent ray. That's it. Then this first ray through face AB is called the incident ray. Good. Now, at this point where the emergent ray touched face AC, I would bring this point of the protractor. Look at this point where 0 to 180 degree line met 90 degrees line, this middle point. I'll make sure I place it at this point. Then this horizontal line 0 to 180 will be lying on face AC or line AC. But I'm going to turn the protractor this way. Watch. Good. I've obtained what I am looking for. So this line AC, you can see that the 0 to 180 degrees line is lying on it. Then these middle points, look at the middle points. That is where the emergent ray met face AC of the prism. So what I'm going to do is to draw another normal at that point. And this is the point of 90 degrees. This is the normal. Okay, so I will remove this protractor, join the normal to this point. This is the normal. Then I'm going to join it to this point on face AC. So this is the normal. I will extend the normal into the prism. I will extend this first normal on face AB also into the prism. So something like this, so that the two normals will meet. You can see that the two normals met at this point. Alright guys, so this experiment is as good as done, alright, in terms of running the practical. Now that these two normals have been drawn to meet at this point, all that is left for you to do is to produce this emergent ray, produce this incident ray. As you are producing these two rays, they will meet at a point. Now take a look, I've actually produced the two lines. Once again, the emergent ray and the incident ray, and they met at this point, you can see that. So here, this point, I labeled it as E, capital E, you can see that. And then I label this point as capital I, this point. Alright, I'm using this E to represent the point of emergence. That is the point where the ray came out from the triangular prism into air. And then here, the point of incidence, where the ray, struck the face AB of the triangular prism before being refracted through the prism. I've decided to join this point of emergence to this point of incidence. This line joining the point of emergence E and the point of incidence I, this line is called the refracted ray. The refracted ray. So you see, this is all about, the experiment on studying refraction using triangular prism. Okay? So your examiner or lab technologist may decide that you measure any of the following angles as I'm going to show you. You might be asked to measure the angle of emergence. This angle. You might be asked to measure it. So the next thing I am going to do is quickly show you how to measure the angle. You can be asked to measure this angle of emergence. Can be asked to measure this angle. This angle is called the angle of deviation. We use D to represent this angle. That is the external angle between where the emergent ray which was produced and the produced incident ray. where they met, the external angle there is called the angle of deviation. You can be asked to measure this angle where the two normals met inside the glass. Here, you can be asked to measure it. Can be asked to measure this one outside. You know, any of the angle, it is the choice of the examiner or the lab technologist to tell you what to measure. Definitely the instruction will be given to you. Perhaps you may have it in your manual. So let us quickly see how we measure these angles, all right?